In this question, I would like to calculate the sum of all moments about point A. These moments are generated by forces F1, F2, and F3. And from the definition of moment, we know we need the force and the perpendicular distance between the force and the point of rotation. So if you look closely to the example here, we see for F1
and the minus sign,
there is no perpendicular distance between F1 and point A. That is 1. And for
sum of all
F3,
rotations about A,
we also don't have the perpendicular distance between F3 and
clockwise.
So we need to resolve these forces into their x and y component to be able to see if we'll find the perpendicular distance. And from the look of the question, it is clear that we will have the perpendicular distances. So let's resolve each force and see for ourselves. So this will be the x component for F1, and this will be the y component for F1. This will be the x component for F3, and this will be the y component for F3, and F2 is same, it is lying in the same axis of the x. Now step number 2 is to check the distances. So we see clearly here that for F1x we have the perpendicular distance, which is from here to here, so this is good. And for F1y the distance is from here to here, that is also good. And for F3, this is the F3x, this is the distance, which is also given. And for F3y, it is passing through the point, so it will make no rotational effect to it, so we don't even need the distance for it. It doesn't have distance actually. The distance for it is equal to 0. So that's why. Now for F2, we have the perpendicular distance for this force. So we'll start to define the rotation direction for each one of them. So for F1x, maybe it's a good idea to write down this is F1x, and this is F1y, this is F3x, this is F3y, this is F2 or F2x will be same thing. So let's first of all define the rotation direction for each one of them. So this will rotate in this direction, which is counterclockwise positive, and this will rotate in this direction, which is clockwise negative. This will rotate in this direction, which is clockwise negative. This has no rotation. This will rotate in this direction, which is counterclockwise positive. So let's go and calculate the values for these forces, each one at a time. So let's see, for example, F1x is equal to this value, and F1y is this, and F3x, and this is F3y. So you can update the sketch with these values if we need to. Now all we need to do now is to start to calculate the sum of all moments about point A is equal to how much. So we'll do this. We take one at a time. So we have F1x is positive, so 1 plus F1x, and the distance for F1x is given as 5 plus 8 is equal to 13 meters. And for F1y is negative, minus F1y multiplied by the distance is given as 6 meters. And then we have F3x is negative, minus F3x multiplied by a distance of 8 meters. And then F3y doesn't have any rotational effect, as we said. And then we have F2 is positive plus F2 multiplied by distance of 4 meters, and the answer is equal to, the end result is equal to minus 19.65 kilonewton meter, and the minus sign means it is clockwise, so the sum of all rotations about A is equal to 19.65 clockwise